Welcome, and thank you for joining the Broadband Forum's Cloud CO video demonstration. My name is Craig Thomas, and I'm the Senior Director of Strategic Marketing here at the Broadband Forum. And it's my privilege to host and introduce this Broadband Forum virtual video demonstration for the Cloud CO, which incorporates our work on broadband access abstraction and, for the first time, the user services platform. This year, we have been very fortunate to be supported by 9 industry-leading vendors and renowned international interoperability labs. All are members of the forum and major contributors to our work. As part of this remote demonstration, we have aligned engineers, equipment, and labs from 3 continents into a single integrated Cloud Central Office demonstration. This global participation is also represented by my co-presenters. They represent both the Broadband Forum and their multiple organizations, and they are participating virtually and demonstrating from Asia, Europe, and North America. In addition, I would like to thank 4 global leading service providers for validating and highlighting the importance of our specific work as part of their own broadband network deployment and end-user service strategies. So as I mentioned, this is a Cloud CO demonstration which involves both our broadband access abstraction and user services platform. The demonstration really throughout offers key attributes and focus in some very specific areas. Firstly, zero touch, both from a service creation, a service relocation, and the user services themselves within the home. Virtualized functions, as inherently within any Cloud CO environment, you need that function virtualization to assure compartmentalized, scalable, and robust solutions. Software-defined and automated, driven by SDN and fully automated solution sets throughout the demonstration today. As is a multi-vendor environment that complements an entire ecosystem and also proves multi-vendor interoperability and certification. All deployed with open source elements, and specifically from this demonstration point of view, working closely with ONAP within the domain orchestration. Migration and coexistence with today's broadband network, creating the new blueprint for Cloud CO broadband, and the enablement that you can coexist and offer a path of migration from your legacy investment. And finally, open broadband standards, offering the industry best practices and those open standards that mean that you can deploy fast and at a low perspective. So I hope I've set the scene nicely for you, but now to talk further about the focus of the Broadband Forum and the paradigm shift that this specific work in Cloud CO is enabling, it is now my pleasure to introduce Mauro Toloca. Mauro, over to you.
Hi, and thanks for joining us. My name is Mauro Toloca. I work for TEAM in the Technology Innovation, Standardization and IPR department. I deal with access network softwarization and, generally speaking, telco transformation. I am very happy to introduce this demo in both my BBF roles of Chair of the Service Provider Action Council, the community of BBF service providers and network operators, and lead of the story team in the OB-BAA project. This Broadband Forum demonstration spotlights network transformation and innovation, leveraging on a combination of rigorous standard specifications, quality open source software components, and a collaborative lab test environment. But first things first. The BBF has produced for more than 25 years many specifications that have become de facto standards, largely adopted for worldwide broadband and ultra-broadband service deployments. Since a few years, our industry segment has initiated a digital transformation path, which clearly called for more, on top of BBF's excellent track record as traditional standards developing organization. This led to launching Open Broadband, OB, an overarching BBF initiative that brings together open standards and open source as the new fundamental legs to support our community by industry-relevant specifications, as well as reference implementations of key components. This is a fundamental paradigm shift in the way BBF is delivering value to its stakeholders. This demo is based on BBF's flagship architecture named CloudCO, and disruptive open source components like the Broadband Access Abstraction Layer, BAA, and the Universal Services Platform, USP, specified in mainstream BBF work areas and developed in dedicated OB projects. This demo speaks to solution developers, network operators, and service providers in that it showcases network and services agility, automation, and orchestration by means of softwareization, virtualization, and cloud technologies. Without anticipating too much, I have to say that as much as the demo is very rich in content and features, it does not pay justice to the tremendous work behind it. This demo is a natural ramp-up of those successfully showcased in 2018 and 2019 at the Broadband World Forum and other venues. Today, it involves more network domains, more operations and service dynamics, and a wider group of solution manufacturers, some of them competing in the same market segment, but unified by a vision of interoperable and streamlined service deployments. A true nirvana for operators. Still, this is just the tip of the iceberg. Behind the solutions part of this setup, there are BBF standards, often referencing other bodies' work, while certain software components in this demo are coming out of open source projects where member companies are joining forces around keystones of CloudCO-based architectures.
Thank you, Mauro, for such a clear and concise vision and introduction to this part of the forum's work. So, moving along, it's now my pleasure to introduce Carsten from ENTC and firstly Lincoln Lavoie from UNH IOL. Both are not just major contributors to the work of the Broadband Forum, but are also key providers to the testing and certification work the forum provides to the industry. It is their labs that were critical in enabling this virtual demonstration. So, Lincoln, over to you.
Thank you, and hello everyone. I'm a principal engineer here at the University of New Hampshire Interoperability Lab, and I currently have the privilege of also serving as the Broadband Forum's technical chair. The Interoperability Lab is one of the open broadband labs, and this year we're hosting resources for supporting the development and next generation of broadband technologies and devices, such as this demo. The lab works closely with many of the Broadband Forum's members and open source communities and that have made this demo possible. Over the last several weeks, we have worked with teams from around the world to bring together an expanded version of the CloudCO into reality. First and foremost, I'd really like to say thank you to all those contributors that have made this possible. The demo is built from the ground up of components from their vendor community, including Altice Labs, Altran, Broadcom, CommScope, DZS, Nokia, and VMware, along with open source components from ONAP and the Open Broadband BAA project and OB-USP agent. The CloudCO architecture, as you can see, is developed from a framework for operators to move to deployments using disaggregation and virtualization concepts. Key to this architecture was standardized interfaces and APIs between the various components of the architecture. So if we dig into the architecture a little bit deeper from the context of the demo, we'll see that the team has actually built while the layered structure remains intact. Here, the open source ONAP instance is serving as the domain orchestrator. Swisscom provided a sample business application portal to show how network operators' business personnel could submit orders and monitor services through ONAP. Southbound of ONAP, we have the Nokia SDN controller, which is enabling SDN control over both the access and the premises networks through either the BAA reference implementation or CommScope's premises controller, which is then controlling the Wi-Fi RG utilizing the Broadband Forum's USP protocol. The OB-BAA layer is able to abstract the access network equipment from Altice Labs, Altran, Broadcom, DZS, and Nokia, meaning the interface to the SDN controller becomes uniform and well-defined. Also, within the BAA layer is the first open source reference implementation of the Broadband Forum's virtual OMCI specifications, which enables the white box OLT from Altran and Broadcom team. On the right-hand side, Swisscom also provided a demo edge domain SDN controller and the virtual BNG to the ONAP use case. So with this kind of deep dive, I'm going to hand you over to another community member, Karsten of EANTC, to look more closely at the lab implementations and the overall design of the demo.
Thank you, Lincoln. I'm CEO and co-founder of EANTC, the European Advanced Networking Test Center in Berlin, in Germany. So this demonstration uses the Open Broadband Labs, both in North America at UNH-IOL with Lincoln's team, and in Europe at EANTC, to emulate a functional distribution and hierarchical deployment of the building blocks. Such distributed data center infrastructures are typically seen in service providers' networks. So we believe we're pretty realistic here. In this case, the customer portal and the domain orchestrator, ONAP in this case, are located at the UNH-IOL, as you can see. And these functional blocks represent the centralized data center of the service provider. Additionally, the access SDN management and the control function, along with the broadband access abstraction, the BAA layer, are at the same location. And these components represent the aggregated edge functions. In contrast, the premises SDN and edge management and control functions are located in the ENTC lab. They represent, in this case, the regional or aggregated edge locations. Now, where would we put the actual premises equipment? Last year, we had demonstrations on the show floor of the Broadband World Forum in Amsterdam. And obviously, the show floor housed this equipment last year. But this year, since the demos are run virtually, the virtual edge access and premises equipment is actually located across the world at participating vendors' labs in Australia, in India, in North America, and various locations in Europe. The placement of these building blocks, as you can see in the diagram, is simply an example to show that the functions can be distributed to locations as appropriate. We chose these locations for convenience, such as, for example, pre-existent infrastructure and services at the two Open Broadband Labs. The labs have collaborated for Broadband Forum projects and generally for distributed and remote testing across multiple vendor locations, which has been set up at the OB Labs since 2019 already. For example, there isn't any reason that the BAA layer couldn't have been deployed to ENTC lab or even on the show floor or vice versa. So it's just for convenience. In any case, it works. And we're going to have an upcoming demonstration where we will demonstrate the creation, the activation, the monitoring, and the relocation of a 1 gigabit per second high-speed internet access, HSIA service. And this service has been configured to include proactive monitoring of the subscriber's home Wi-Fi solution. And this Wi-Fi monitoring aspect really shows the power of closed loop automation and the ease of deploying additional services into the cloud CO architecture, where the systems can build upon the BBF's standardized interfaces, APIs, and data models. So that's it from me so far. Thank you, and over to you, Craig.
Karsten, thank you. So let's now go straight into the Cloud CO demonstration. Andre from DZS will be running through the Cloud CO service creation utilizing OB-BAA. But first, let me hand over to Bruno from Vodafone, who will share with you the importance of Cloud CO and especially zero-touch provisioning. Bruno, over to you.
Thank you. My name is Bruno Cornaglia, and I am a fixed access senior manager in Vodafone. My role is to manage roadmap innovation for all access technologies, including copper, not allowed today, cable, and fiber. I'm here to present to give the value of zero-touch provisioning in operator networks. Zero-touch provisioning is really important in an operator network because not only give the opportunity to reduce human resources, that is OPEX, but also to give the opportunity to reduce the risk in operations. First of all, will give and to deliver value to the end customers. First of all, it increased the reduce the time to market. So because the time to activate the card will decreases and will be lower, and so the customer is happier. We have operational cost reduction due to human resources, as I said before, that will be reduced. But also there is another important value, that is the risk of misconfiguration, that is also reduced, because at the end, by automatizing the entire process that you can see on the right part of the slide, you can obviously reduce the risk of having misconfiguration errors, and so making the customer happier. All these values will create a big value for the operator, that is reducing the time, reducing the risk of misconfiguration, also make the customer value, and so you reduce churn. Churn is a high cost in an operator OPEX, and that's reducing this type of cost is really a big value. We maintain the customer. We don't need to look for other customers to replace the ones that are going away. That's the main value that zero touch provider can have directly can deliver. But there are also other opportunities that zero touch provisioning can deliver to end customers. There are other opportunity of businesses. For example, customer self provisioning for for example, for certain customers. I'm talking about business customers or something like that will need to change their configuration by their own. They can pay something. They can add. They can access via standard APIs to the system, and then you can change some part of them. For example, you can add bandwidth on demand. Bandwidth on demand means that at the end you can, for a certain period, you need a higher bandwidth in terms of guaranteed rate, in terms of peak rate, and then you can change and to pay a little bit more for this extra value for a certain amount of time. That you can have dynamic bandwidth allocation. That means that not in terms that you can change the bandwidth according to the service that you are using. So automatically do these changes. So there are other opportunities that this process, if it is on board in an operator, we can have in the operator side. That's all from my side. I will leave the floor to Andrea.
Thank you, and hello everyone. My name is Andrea Oelschläger. I'm head of the DZS R&D team Germany. Our software team is contributing to the OB-BAA open source software. I will now start with the first part of the demonstration. The first step is the service request. This happens when the subscriber orders the broadband services through the service provider's customer portal and associated BBS systems. This is shown on top of the slide. As part of fulfilling the subscriber request, the service provider registers an end device and ships it to the subscriber. Then the system waits for the subscriber to simply connect the device in the subscriber's home. While we are showing in this demonstration that the service provider ships their branded devices, the zero-touch operations are also applicable for retail devices selected by the customer. In this demonstration, the ONEP open source platform is used to create the service for the high-speed internet access. It also provides the service monitoring and the new added Wi-Fi monitoring services. In our setup, ONEP keeps the service information until the network will inform ONEP on which port the device is attached. ONEP will then push the service request to allocate the network resources. Now I will show you the portal and I will create the service request. On the customer portal, we are easily selecting the 1 gigabit service. The service request will create the work order in the BBS system. In the work order form, we added the option to select the vendor ONUs with pre-configured vendor information. Also, we added additional features for customer-provided residential gateway and Wi-Fi monitoring. As last step, we will now confirm the order. The BBS system will now show the status of the order. Meanwhile, the equipment will be shipped to the customer. After activation of the customer device, the system will report that the order is completed. In our demonstration, we have established VPN connections to the vendor labs. Now we will have a short look to the vendor equipment from Altice Lab, Altran and Broadcom, DZS and Nokia. In the first video, also a short activation sequence is shown. The ONU LED goes to green after the 1 gigabit link was established. The service is activated shortly after, and the web page on the monitor is updated. So, from the short video clips of the vendor devices, we also showed the service creation and activation. I will give you now some details about the activation process in our system. The first step starts when the subscriber connects the ONU. The corresponding OLT will then discover the ONU, and the 1 gigabit link will be established from the ONU to the provider's wallet garden. The service still waits for authentication. In the second step, the customer will plug in the residential gateway. The premises SDN management and control layer will then add the residential gateway to the network configuration, but also is waiting for authentication. And finally, the residential gateway authenticates to the network, and our system reacts by connecting the subscriber to the internet and by enabling the subscriber Wi-Fi service to begin monitoring of the Wi-Fi network. In this demonstration, the subscriber is automatically authenticated when the device requests its IP address from the network. This entire sequence from request to activation is zero touch, and the time to activate the service is only limited by the time it takes to ship the device and to connect the device to the network. Now I will hand over to my colleagues for the next part of the presentation. Thank you very much for your attention.
Thank you, Andre. Now that we have demonstrated service activation within a cloud CO environment with OB-BAA, we are now going to progress from the access network to the premises and look at how the user services platform automates and delivers gigabit service experience to where the subscriber really realizes the benefit. That is, across the home or business Wi-Fi to the actual user's device. This is the first time we have actually integrated parts of our user services platform into the Cloud CO demo. And to talk more about the service provider's benefits of closed-loop automation for Wi-Fi monitoring, I would like to introduce Francisco de Carvalho from BT.
My name is Francisco de Carvalho, and I'm a senior specialist at BT and a board member at the Broadband Forum. The focus of my work is on the enablement of software-based interfaces on the access network, so that these can be consumed by communications providers in real time. BT and many operators across the globe recognize the need to enable customer self-care as a tool to empower customers so that they are better able to quickly resolve problems. But we also recognize that skill sets within the home vary greatly. Customer center call volumes point to the fact that Wi-Fi reported problems remain as one of the biggest areas requiring support. And often, the problem is either not Wi-Fi related or caused by other in-home equipment owned by the customer and not relating to our products and services. But we still have a responsibility to support our customers. So I'm really upbeat to see the Wi-Fi closed-loop automation standards-based solution become a reality in the context of an SDN-ready implementation. Broadband Forum's Wi-Fi closed-loop automation has two main drivers at heart. First, to deliver an enhanced customer experience. Through network optimization and self-healing, we can be proud of increased customer satisfaction. Service assurance is possible through positive or negative proof, enabling the location of problems to be accurately identified, e.g., is it inside or outside of the premises. Second, to be cloud-enabled. By making use of virtualization software container technologies, the solution removes coupling between the diagnostics engine and having to run on a specific physical device. In turn, this allows for distributed computing deployment at either or both the home equipment and network cloud sitting in the control center. The benefits include the removal of downtime, for example, during upgrades. The Broadband Forum's User Services Platform, or USB, is delivering on the promise of software programmable devices in the home and in the control plane. In this use case and demonstration that follows, we specifically look at an active Wi-Fi monitoring and automation capability that emphasizes the need for and business value of automated control. Further, the USB provides the customer with visibility of the performance of all Wi-Fi connected devices in the home. By taking a holistic approach to device and home network management, remedial actions on the Wi-Fi connection to any connected device can be taken. The ability to have a control mechanism in the home and in the cloud enables real-time optimization through automated algorithms. This gives service providers like BT the ability to proactively and continuously monitor the home or business Wi-Fi network, leading to service assurance and higher customer satisfaction. Broadband Forum's USP with closed-loop automation is an overseeing eye of today's connected home experience. By continuously monitoring the network status and carrying out targeted analytics, closed-loop automation can detect anomalies such as Wi-Fi interference and traffic congestion. Simple but effective actions such as channel reassignment can then be taken, leading to service quality protection. Such self-healing actions are proven to reduce customer support calls. Not having to sit on potentially lengthy call waiting times lead to increased customer satisfaction. In the best scenarios for self-healing, costly engineered visits to the premises can be avoided. All of these lead to reduced operating costs and increased efficiency measures. By defining and building solutions that are compliant to standardized APIs, such as those provided by the User Services Platform, The Broadband Forum enables service providers to support this type of Wi-Fi experience across multiple platforms from different vendors. For example, deployment on a variety of home gateway products with varying firmwares for multiple suppliers. The containerized approach means that operators can make any changes they require to specific functions in the CPE and the network, such as Wi-Fi monitoring and management, without it ever being service affecting or requiring mass upgrade changes, some of which can take many weeks to completely upgrade their large customer base. It is an existing industry development. It's now my pleasure to hand over the microphone and video over to my colleagues, John Blackford and Palani Ramazami, who will now run through the demonstration and provide more details on the feature set available. Thank you for your time and enjoy the experience.
My name is John Blackford, and I'm a product management director at CommScope, the OB-USP agent project leader, one of the Broadband User Services co-work area directors, and the chairman of the board at Broadband Forum. On this first slide, we see the full breadth of the demonstration components. But here on the second slide, we see the more focused area of Wi-Fi monitoring. Here we see some key new aspects of the demonstration as compared to what was shown last year. This year we have introduced the CommScope Premises Management and Control solution that communicates to the RG via USB, and the Nokia Wi-Fi monitoring solution that receives bulk data collection reports from the RG. At this point in the overall presentation, the following preconditions have already been met. The service was created with Wi-Fi monitoring enabled. The customer's RG is connected and the Wi-Fi service is operating optimally. Service creation caused the configuration of HTTP bulk data collection on the customer's RG. And Wi-Fi quality of experience parameters are constantly being delivered to the Wi-Fi monitoring application. Taking a look at the next slide, we jump right into the Wi-Fi monitoring scenario with the detection of a Wi-Fi problem within the home network. And so at first here we have a Wi-Fi interference impacting the home network, which is indicated by this red home here. In step 2, we see the bulk data collection reports being sent to the Wi-Fi monitoring with information about Wi-Fi data and the performance of the environment. With step 3, we see the Wi-Fi monitor identifies the issue and determines that there is a corrective action that needs to be taken, which it then sends up to the premises management and control solution. In step 4, the premises management and control notifies the access domain management and control of the service degradation, which is then exposed on the customer portal. And then in step 5, we see that the premises management and control actually executes the recommended action to fix the issues. On the final slide here, we see that the Wi-Fi problem is resolved without manual intervention. We start with, the corrective action was just taken on the device, and we see that indicated as now it's being green. And then in the second point, we see HTTP bulk data collection reports being sent through up to the Wi-Fi monitor solution, where it then detects that the issue has been resolved so that it notifies the premises management and control. And then in 4, we see the premises management control notifies the access domain management control of the service restoration, which is then exposed in the customer portal. And at this point in time, I would like to turn over the presentation to Palani for him to walk through the demonstration of what I just described.
Thanks. I am Palaniappan Ramasamy, Systems Engineer in Nokia Broadband Devices Business Unit. I am leading a portable home agent software component team, which enables any residential gateway can be manageable from a cloud using a Wi-Fi monitor. Currently leading a USP TR369 agent activities for Nokia, through which agentless cloud can be achieved for Wi-Fi monitoring. Let's watch a demo. On the top of a screen, we have a ONAP dashboard in which ONT is provisioned and the Wi-Fi status is healthy. Second half of the screen is a Nokia Wi-Fi monitor NWCC. It provides the real-time insight to the operator networks. RRM algorithms in cloud help to manage the home Wi-Fi networks in a better way. Summary page provides the basic home network Wi-Fi details, primarily Wi-Fi status and radio. You can see channel 1 and 40 are being used as a current operating channel of RG. Event log shows the actions performed by the RRM and RG. On every boot up, it does the initial channel selection and set it to the RG. You could see it on the screen. Initial channel being set to 40. This demo primarily focuses on channel management. Nokia Wi-Fi monitor provides a graphical representation of a channel usage. You could see it on the screen. The orange circles shows the channel change done by the RRM in the initial channel selection to channel 40. The graph shows the channel usage. We have started injected the interference for demo. You can observe the usage going high. Threshold value is 50% and trigger period is 10 minutes. Whenever average goes more than 50% for 10 minutes, it will trigger the channel change based on the RRM algorithm to the next best available channel. Interferences is injected using a similar device operating on a same channel 40 with a high data traffic on it, which causes the Wi-Fi status goes to unhealthy. In the ONAP dashboard, you can see a Wi-Fi status updated to unhealthy. Event log capture the actions taken by RRM. You could see a threshold exceeds and channel change triggered by the RRM due to a high usage in channel. Current channel moved from channel 40 to 153. Whenever channel usage goes high, Wi-Fi monitor informs premises SDN controller with a new channel to be set, which in turn sends a message to RG using USB protocol. After channel change reported by RG, Wi-Fi monitor in turn updates the premises SDN controller with the status healthy. ONAP updates the Wi-Fi status as healthy. Quality indicators are also good. We can check the updates in the channel usage graph. It clearly shows the channel triggered and moved to the channel 149. Graph depicts the channel usage is dropped to a normal because of RG moved to the best channel. Based on the algorithms, channel moved from 40 to 149 and usage is normal. Wi-Fi moved to unhealthy due to interference. Wi-Fi monitor detects and rectified it. Wi-Fi back to healthy. Current channel is 149 and Wi-Fi status is healthy. Thank you.
Thank you, Palani, for another excellent demo. The final part of our 2020 Cloud CO video demonstration introduces how the OB-BAA work supports service relocation. Service relocation is especially useful when a subscriber is moving home or business and can take his ONT or fiber home gateway with him and experience zero touch and automated services in his new premises. To talk further about this application, I'd like to introduce David from Swisscom, who were instrumental in driving the requirement within the Broadband Forum. David?
Thank you. My name is David. I'm a lead engineer at Swisscom, and I'm glad to be here today to introduce you the service relocation demo.
So at Swisscom, one of the pillars in our strategy is to always provide the best customer experience. And when it comes to fixed access, we have a special case that we call nomadic ONT. So with Nomadic ONT, we are enabling our customers to bring the ONU with them to a new location, such as a new apartment or a vacation home, without having to notify us about the move. So that means that the customer can at any time take the ONU, plug it in the new fiber socket at the new location, and the network will automatically detect the move and do the service relocation so that the customer can have the same experience as it had before. And one example of those services is the high-speed internet access, and that's the one we are showing today in this demo. As an operator, we are always looking for solutions that are truly multi-vendor and use open standards and open reference architectures as much as possible. And for this reason, in this demo, we are relying on BBF Cloud CO framework and open source platforms like ONAP to deal with the automation related to the relocation of the service. And with this, I am going to hand over to Andre from Altice Labs, which is one of the main contributors to the implementation of the demo. And he will explain to you in detail how it was implemented.
Thank you, David. My name is André Brizido. I'm a senior engineer at Altice Labs, and I'm currently leading my company's participation in the OB-BAA project. Altice Labs is one of today's European reference suppliers for the telecom market in what relates to the access network domain. Our strategy is totally aligned with BBF's Cloud CO architecture. Finally, the demonstration shows the relocation capability for when the subscriber moves and attaches to a different fiber termination point within the service provider network. When the subscriber does this, the network recognizes that the ONU is associated with the subscriber, but now it is connected to a new attachment point. The system reacts by reconfiguring the high-speed internet access and Wi-Fi services with the subscriber profile to the new location. While we can show this in the virtual demonstrations, live demonstrations would show how the Cloud CO supports coexistence with the existing network while allowing for migration of selective functions such as view MCI that is now used to manage the ONU instead of the OMCI that was embedded in the OLT of the original attachment point. In many cases, when subscribers relocate temporarily or permanently, the time to re-establish the service goes from days or weeks to seconds or minutes. As you can see in this live demo, the fiber is switched from one attachment point to another, simulating the subscriber relocation. In this live demo, we can see that the system has detected the relocation by switching the order back to processing. At the same time, the devices are reconfigured and the high-speed internet service re-established.
This is before relocation. Internet is already up.
Andrea, thank you. So that is a wrap for our Cloud CO video demonstration. We have highlighted how the Broadband Forum work in OB-BAA and USP contributes to the Cloud CO framework, with multi-vendor compatibility and extending to new functionality, making the software-defined Cloud CO even more expansive and automated. This was highlighted with many new aspects to our demonstration, such as the disaggregated OLTs with virtualized OMCI, which is leading to a realized white box model. Also, open standard distributed BNGs within the Cloud CO framework. And finally, USP's centralized closed loop testing for automated Wi-Fi provisioning. If you've enjoyed this video demonstration and are interested in joining the BBF to monitor or to contribute to our broadband work, please do not hesitate to contact Rhonda Heyer, our Director of Membership Development. Or you can email us at info@broadband-forum.org. Thank you very much.